Okay. There's another phenomenon that we need to understand. Glare, right? Most of the reasons why daylighting doesn't work is probably because of this issue. There are two types of glare, direct glare and indirect glare, or reflected glare. And direct glare is, we talked a little bit about that, and the reason is eye adapts so rapidly with different brightness ratios. So sometimes it's too hard for the eye. It's very sensitive. It's too hard for the eye. So that's one of the reasons why you don't want to stare at the sun, right? But the inherent nature of eye is our eye will normally get attracted to bright light. For instance, if you're driving, how many times you turned your head to look at the bright light coming from another car in the opposite direction? Because our eye naturally wants to just look for bright spots. But sometimes we use that nature of eye towards design. When you go merchandise design in a mall, they just usually pump up the luminance of sometimes of the displays so that you look at their store as opposed to the next store right down. So it's important to know those two things. Sometimes, the another important thing to understand is, let's take the car headlight example. If it's during the night, and if that headlight is directly shining at you, then that's glare. That's a problem, right? But if it's during the day, and if that headlight is shining directly at you, is that a problem?
No.
Why? Okay. So when we're dealing with glare, we should think about that aspect of lighting also. Okay? So in a classroom, typically glare comes from two sources. Direct glare comes from two sources. One source is obviously the windows, and the other source is the normal lights that we have, the direct lights that go down. And I'll talk about that in a second. But when it comes to any source, the answer to solve direct glare is not to reduce the number of source that causes glare. The answer is to reduce the amount of luminance that they put out. So if you have a very bright light, you want to reduce the amount of luminance to reduce glare. But there's a balance. So if you keep reducing the amount of luminance that a light puts out, you're going to reduce the amount of illuminance on the work surface. So how do you balance that? So that's very critical. And reflected glare is more complicated. The wheeling reflection that we get off of the magazine when we read a magazine, and the phenomenon is because of the angle of incidence being equal to the angle of view. In a normal task like reading or something in a classroom or an office, our normal angle of view is between 20 and 40. That's our normal angle, 20 degrees to 40 degrees. So if your light fixture, the way it emits light out, is also in this 20 to 40, we're screwed. So that's why most of the downlights are not always good for wheeling reflection issues. And the other wheeling reflection issue is on a monitor, right? If you see the monitor is usually pretty reflective. And that's why we go to the non-reflective monitors. But the reflective monitors usually reflect the light source back at you. So you can't really see anything on the monitor. So it's important. That's why it's important to place the office layout and understand where the monitors go when it comes to downlighting. So the simple solution is, if you have a magazine and if you have wheeling reflections on the magazine, just tilt the angle, you're good to go. If you tilt the angle and if you don't receive enough illumination on the magazine, can you still read? Okay, so let's say you're reading the magazine, right? I'm reading it like that. And let's say it has a reflective nature. Magazines typically have those reflectance. So because if it's a specular surface like the magazine, it'll reflect. This is not a specular surface; it's not going to reflect. So I won't have any wheeling reflections on a piece of paper like this. But on magazines, typically we do. So when I get a wheeling reflection from a light source like this in a magazine, and if I do this, tilt the angle, because I'm no longer angle of incidence equal to angle of view. So I avoid wheeling reflection. But can I still read?
Yes.
Because the amount of foot candles that falls on this, the illuminance changes, right? I have 50 foot candles now. I do this, I may only have 40. Can I still read? Yes, and that is because of our adaptation nature of the eye. That's also because how high the contrast on that task object is. Because if this contrast is not good enough, like we talked about before, we need to start illuminating this more. Okay? So the simple solution might be change the angle. So we'll look at how to change the angle. So if this is a typical luminaire, between 0 to 45 is the direct glare zone. Reflected glare zone. Between 45 to 85 is the direct glare zone. So ideally, we want to place our work surfaces in between so that we don't get the harshness of both. So that's why if you in an office layout, if you have a row of light, you always place, you don't put anything right below it. You always place right next to it at a 45-degree angle. Make sense? Okay. When it comes to glare and brightness ratio, when it comes to glare, it's important to understand the maximum brightness ratio that I can comfortably take, and this is recommended by IESNA. This is very, very important to know. Okay, let's say this is a classroom environment, and so primarily the view angle is towards the teaching wall, right? And you may have windows on the side. So if there is 1 foot candle on the teaching wall, or not foot candles, this is luminance. When it comes to glare, it's not, we don't care about how much light falls on the surface. What we care about is how much light is reflected back from that surface. So glare does not deal with illuminance. Glare deals with luminance. So let's say that did I confuse you guys? No? Good? Okay. Glare, when it, let's say in that teaching wall, in that we have 1 candela per meter square luminance reflected off of this board, whiteboard. Then the maximum allowed on the surrounding wall on a light surface is 10 times of that. So where does this help us? Say you have a window here, and it's 3 o'clock in the evening. Sun will penetrate through that window, and it will just wash this entire wall. If the amount of lumens that reflect off of this wall is above this 1 to 10 ratio, nobody can see a damn thing. So that tells us how much we need to do glare control. So it's very, very important. The moment you change that surface to a dark surface, you can go to a higher brightness ratio. Likewise, between a window and this surface, the maximum you want to have is 1 to 20. So that's why putting a shade in front of our window helps a lot. Because if you don't do that, it's direct sun hitting directly at the window. So the ratio between this surface and that surface is more than 1 to 20. So then it will be difficult for people in that environment.
Why is 1 to 20 with the dark surface allowable?
That's because of the reflection nature of that surface. Dark surface typically reflect less if you don't have a dark shiny surface.
Right.
So since it reflects less, you're allowed to put more light on it.
Oh, okay.
Likewise, you don't want the floor to be too bright, so the ratio is 1 to 1/10. And then likewise, the immediate surrounding around your work surface should be 1 to 1/3. This will be more understandable as I show an example. I'm going to run through this quick.